169, we are going to go with Kayla.
Describe the two types of diabetes mellitus. C?
C is correct, right? So type 1 being inadequate insulin production, or you're not making any insulin due to auto antibody destruction of the beta cells, of the islets of the Langerhans and the pancreas. And type 2 is usually insulin resistance. The receptors are not as functional, right, due to your genetics, or you have obesity, so receptors are not as functional. These patients can also have, lack of insulin production eventually, and they may need to go on insulin. Also, type 1 are more susceptible to DKA. Type 2 can go into DKA, but usually they do not, because they make small amount of insulin. So that starves off production of lipolysis. And they're more likely to go into this condition called hyperglycemic, hyperosmolar, non-ketogenic coma, right? Hyperosmolar, hyperglycemic, non-ketonic coma. By the way, do you know why they call this? Why there's such a complicated name? Hyperglycemic, hyperosmolar, non-ketogenic coma. If someone could tell me, I would be highly impressed.
No one's impressing you today, Nikolai.
Nobody learned about these conditions, right? Nah. You guys want to know? Would you like to know or no?
Yeah.
Would you like to know? All right.
Yeah.
So in our blood there's something known as osmolari, and we could measure that, right? That's basically all your cations and anions, right? The particles that are flowing in your blood, they create an osmotic pull, right? They basically do so, right? And they're in equal amounts. And what I mean by that, like, you'll have your positive charges like potassium, right? You have your sodium. These make up your, cations. Then you have like your chloride, right? Your bicarbonate, your proteins. These make up your anions, right? Like proteins, negative charge. Protein, phosphates, PO4. So they're in equal amounts. The pluses and minus are in equal amounts, right? Now, this makes the osmolari. Normally, if I check your osmolari, right? Your osmolari will be roughly, on a normal person, about maybe, 295 milliosmoles per liter. Right? If I check your osmolari, if you look on your normal saline, right? Next time you're in the lab and you're doing your piggybacks, look at the saline. Saline will be isotonic, right? So the osmolari of the saline will be around this range, right? So roughly speaking, it's 295 milliosmoles per liter, right? Now, in a setting of hyperosmolar, hyperglycemic non-ketonic coma. So what happens, right? And the way we could actually calculate, if I have your blood work, right? Let's say you come to the hospital, I draw your blood, right? And I put it in a test tube. I could calculate your osmolari. How do I do it? There's a formula for it, right? It's roughly 2 times your sodium, so your positive ion, right? Plus your glucose, amount of glucose in your blood, right? I check your blood sugar level, and that's divided by 18, plus your blood urea nitrogen, right? That's your one of the tests, right, for your kidney functions, and how much of a concentrated urine you have, divided by 2.8. So let's just say, I'll give you these numbers so you guys see how this is calculated. Your sodium level, right, normal is about maybe 135, right, in your blood, times 2. Your glucose, let's suppose your glucose is 180 milligrams per deciliter, right, divided by 18. And we're going to say your BUN is 28. It's slightly lower, right? It's like, if you're not dehydrated, it will be like 20, 22, 23. Divided by 2.8. The reason why I'm keeping these numbers, so it's easy to divide, right? So 2 times 135 is how much?
270.
270, right? 180 divided by 18 is 10, right? And then 28 divided by 2.8 is also 10. So here, right, we get about 290 milliosmol, right, per liter, right, which is this, right? This is how we get your normal osmolarity. Now look, in the setting of a diabetic who doesn't have insulin, right, or insulin resistance in type 2, right? This is what we saw, right? In type 2, right, we see insulin resistance. So what happens is their body starts to break down glycogen stores, right, and release them as glucose because it's thinking it doesn't have sugar because of lack of insulin. So their sugar level goes up. So instead of their sugar being 180 here, right, let's say their sugar now, elevated, it becomes 380, 480, right? Maybe in those conditions it could become like 680, right? It could be very high. Let's just suppose it's 600, right? So the sodium is the same, their sugar goes up, right? And because they become hemoconcentrated of the sugar dump, right? Their BUN may increase. Their BUN may become a little more, right? Maybe 34, 33, let's just say 34, divided by 2.8, right? So if I use my calculator, right, and I divide these numbers, right, so this is still 270 plus, we're going to say 600 divided by 18 is 33 plus 34 divided by 2.8 is 12, right? So all this is equal to 315. So this is my osmolarity, right? So you see how my osmolarity is increasing. Why? It's increasing because my sugar is going up. Why is my sugar going up? Because my body's breaking out glycogen stores, or it's breaking down amino acids, right? Formation of new glucose. It's making lactate to make new glucose. It's breaking down lipids, fatty acids to make new glucose, gluconeogenesis. So my sugar in my bloodstream is going up, but I have no insulin. I need insulin shot. This makes me more hemoconcentrated, so my BUN ratio goes up. All of this is making my osmolarity higher, right? So I went from 290 or 295 normal to 315. That's why we call it hyperglycemic, right? So they're making a lot of sugar. Hyperosmolar, because my osmolarity all of a sudden is now 315. It's non-ketogenic. So if I check your urine, you're not making ketone bodies. You're not making ketone bodies. Why are you not making ketone bodies? Because your pancreas is not fully destroyed. It's making very little amount of insulin, not enough to cause sugar to drive into the cell, to starve off this, excess glucose production, but just enough to starve off ketogenesis, formation of ketones, and to stop off lipolysis. So it stops these processes. So it's non-ketogenic. Why do you go into coma, right? So do you know what is the major cause of altered mental status in the setting of DKA and HHNC? What is the main reason patients go into AMS?
Acidosis?
Not as it's a good thought process. A lot of people think it's acidosis. It's actually osmolarity, right? The moment you exceed this number, right, you become hyperosmolar, right? In the setting, you basically start to develop altered mental status, right? So that's why it's important to control that. And so this is the main reason why the patients type 2 diabetics, right, they go into this HHNC. Patients in type 1, right, they go into DKA diabetic ketoacidosis.
I'm guessing the osmolarity has some sort of effect on neurons. That's why.
Correct.
Okay.
Right. You basically you are adjusting your electrolytes where there's now imbalance between the two, right? And that's also how they measure their anion gaps, right? Anion gap, something you will see in the lab work for patients in DKA. They have more fixed acids and causing anion gap to form. But for your purposes, you don't need to know the formulas. You don't need to calculate any of this stuff. the reason why I am showing you this, right, is when they tell you, okay, HHNC, hyperosmolar, hyperglycemic, non-ketogenic coma. You're like, what the hell is that, right? You all know, right? Okay, type 2, they may have it, but how do they get the name? The way they get the name is the first hyperglycemic that comes from high glucose production through breakdown of all the glycogen stores and gluconeogenesis, forming new glucose from non-carbohydrate sources like amino acids, fatty acids. Why is it hyperosmolar? Is that when your sugar goes up and your BUN goes up to hemoconcentration, right, your osmolarity goes up based on this formula. So you may become 315 milliosmoles per liter, where your normal range is 295. Why it's non-ketogenic? Small amounts of insulin production, right, stops formation of ketones, right? And while you go in a coma, you have the high osmolarity in your bloodstream, right? That's what precipitates that altered mental status or altermentation.